Hello, my name is Mathieu Liénard and welcome to my series of videos demoing my Pexip Infinity video conferencing platform with AWS services. In this series of videos, I will switch gears a little bit, moving away from the fun and hype of Alexa and AI services to get our hands dirty in the backend, talking about logs and support. Like in other IT domains, as a unified communication and collaboration engineer, one of the main difficulties doing support is trying to find the relevant logs and make sense of them. In this series of videos, I do not have the pretension to solve that problem. But as you see, applications are also moved to the cloud, and cloud service providers do provide tools to store, manage, transform, query, and perform analytics on logs and data. What I will try in this demo is to explore what can be done with those built-in services and my Pexip Infinity platform. Before we get our hands dirty with the demo, I want to mention a few important things about it. First, the format will be a bit different from the previous ones, where I was doing one video with the demo and one video explaining the technical details of how it was working. In this series, I will walk through the technical details while performing the demo. Second, and more important, with the second video of this demo, I will release on GitHub all the code I have written, together with a CloudFormation template in YAML for you to automatically provision almost everything on AWS that is shown in this demo. The GitHub page is ready with some details. If you want to check it already, click the link below. But I haven't published yet the code and the YAML template. This demo will be split into two videos. The first one is about getting the logs into the cloud logging service, wrangling the logs into JSON, and storing our nicely structured logs. The second video will show how we can then query the logs, and will provide you the code and CloudFormation template for you to use it on AWS. Okay, enough talking, let's get into the demo. The first step to deal with all those logs using AWS services is to send them to CloudWatch Logs. In order to do so, I have set up a Linux syslog server on an EC2 instance, and I set up Pexip Infinity to send both the support logs and audit logs to that EC2 instance. And I install and configure the CloudWatch agent on that Linux VM to send all the logs periodically to CloudWatch Logs to two distinct log groups. One log group that we can see here is for the audit logs, and this other log group is for the support logs. First of all, let's look at the raw logs inside the Pexip management server. There are two main types of logs. The administrator or audit logs, which are more of the low-level Pexip server / process logs, and the support logs, which we are looking at right now, which are mainly the communications logs together with some application logs. As we could see going through all those support logs, looking for some information to troubleshoot a problem will quickly become very difficult, even if there is a search tool. So once we have deployed and started everything, if we look into CloudWatch Logs, let's take the audit logs of the management server, we can see that we receive all the logs. I look into some details. We can perform some basic search here. Let's take the service stop logs. But at this stage, it is not much more useful as the Pexip Infinity built-in logs view. But what we can do with CloudWatch Logs is to subscribe a Lambda function to the log group so that each time it receives logs from the syslog server, it will send them to that Lambda function. Here we see for both log groups for the audit and support raw logs. So there is a Lambda function which is subscribed to those two log streams. The purpose of this first Lambda function is to process the logs and format them into a nice and clean JSON format. Each time a batch of logs is received by CloudWatch Logs, it will trigger a new instance of that Lambda function which will process those logs. As more logs comes in, CloudWatch Log will trigger a new execution of that same Lambda function and process those new batch of logs in parallel. Once the Lambda functions are done formatting the logs into JSON, each one of them will evoke an export function which will copy those logs into files in an S3 bucket and export back into a different log groups inside CloudWatch Logs, which you can see here. Few things to note here. On the S3 side, when exporting the logs to S3, that Lambda function will group the logs by type of logs like zip, ICE, REST, etc. for the support logs, and then date. For example, here, if we look at the support logs, it's organized by type of logs and then date. When manually searching through logs, you want to have all the logs that occurred at the same time together. So it is tempting to group them by date first. But for a query and analytics tool to search for logs, the search will be much more efficient if all the logs of the same structure are grouped together. So this is why logs are stored in S3 by type of logs. And we will see in the next video how this comes in handy. On the CloudWatch side, two things to note. Each Lambda export function will put the logs into a separate log stream. If I look into the support logs, here we see their different log streams, each containing a batch of logs. The reason for this is that to write logs into a log stream, you need to grab a token. But as functions are executed in parallel, you will inevitably end up in the situation where two functions are trying to use the same token to write logs. That will make the export fail, and basically you will end up with missing logs. So to avoid that, the only solution is to get each execution of the export function to put the logs into its own log stream. So each of the log stream you see here is the output of one execution of the export function. The unfortunate side effect of this is that logs are then neither classified by time nor by log type, but grouped by a batch of process logs. But we will see in the next demo that the fact that the logs are stored here in CloudWatch Logs in processing order instead of time, for example, is not a problem. So using an EC2 syslog server, CloudWatch Logs, and two Lambda functions, now if we look into CloudWatch Logs, we can see we have here we are looking at the audit logs, which are now in a nicely structured and readable JSON format. And if I look back into some logs in S3 that I've downloaded, here we are looking at some support logs. So these are zip messages. We can see also that they're nicely stored as a JSON event, which will be helpful in the part 2 of the demo. So that's it for this part 1 of the demo. As you could see, we are not finished yet, but I hope I got you excited for part 2 and the delivery of the code and the CloudFormation template for you to try what I am presenting in this demo. Thank you for watching and see you next time.